Good evening. So now we will see. So you can go to this playlist. So here you can have M3 questions. That is on your first part of Unit 1. That is complementary function and particular integral. And then we have strength of material, that is mechanics of structure. And some part we have that is of fluid mechanics. So now we will go with this question. We will find first reaction and then we will go SFD and BMD. So now we will have this 5 kilonewton per meter load throughout. Now you have to keep in mind this is though given kilonewton per meter, this is 40 kilonewton meter and this is 60 kilonewton meter. So now we can have moment about B equal to 0. And then total distance we have 2, 3, 5 to 7 meters. So total we have 7 meters. Therefore, VA into 7 minus UDL, we have total 7 meter. So 7 by 2. Then we have this moment clockwise. So we have plus 40 because due to VA, we have clockwise. And due to UDL, we have anti-clockwise moment. So 40 we have clockwise, so plus 60 we have anti-clockwise. So minus, and that is equal to 0, from which we will get value of VA. And we have this value that is 5, 7 square by 2 plus 20 divided by 7. So it is value of this we have that is 20.36 kilonewtons. 20.36 kilonewton. Then we have summation Fy0. Now as it is y, Fy that is force. So no moment will be considered in this. So 5 into 7 plus Vb and that is equal to 0. And therefore we will get Vb that is equal to 35 minus 20.3 and we have this value 14.64 kilonewtons. So VA 20.36 kilonewtons and VB 14.64 kilonewtons. Now we have these two reactions. So this is 20.36 and then we have this as 14.64. Now we will go with shear force. Shear force. So where we have to find first? Left of A, 0. Then we have right of A. So right of A, we have 20.36 kilonewtons. So plot it simultaneously. So we have 20.36 kilonewtons. And then directly we have left of B. Because we are not going to find at point of couples because moments are not considered. And therefore we have directly that is left of B 20.36 minus 77 into 5. So minus 14.64 kilonewton as it is x to the power 1 UDL. So we have this will be x to the power 0 as it is UDL. So we are going to get it as x to the power 1. So we can have x to the power 1 and then we have 4 that is right of B and it is 0. So simple, right of B, it is 0. So the problem you will see that is complicated, but it's very simple. Now BMD we have a little bit complex we can say. So now shear force 0 we have to find out. Fifth point, shear force equal to 0. So simply we have reaction 20.36 UDL we have 5 into x equal to 0, and we will get this x equal to 4 point. So you 4 point. So 20.36 by 5, 4.07 meters. So we have this 4.07 meter. So this distance. Now we will go for bending moment. So now we have bending moment. So we have to find bending moment that is at A. So we have at A value is 0. So bending moment. Bending moment. So we have at A 0. Now we have to find, now couple is there. So we have left of D. Where we have couple, we have to find left and right in bending moment. So we have 20.36 into 2 minus UDL we have 5 into 2 by 1. And we will get this value 20.36 into 2 minus 2 by 2. So we have this value 30.72 as it is x to the power 1 UDL x to the power 0 which is in loading. So we have this will be x to the power 0 in loading. Then SFD we have x to the power 1. So BMD we have x to the power 2. Everywhere we have x to the power 2. So we have this value 30.72 kilonewton meter. Then we have third, a right of D. So we have a right of D. And we have to simply go, we have clockwise. So 30.72 plus 40. And we will have this as 40.72 kilonewton meter. So right of D means we have to plot there only. Then we have zero shear force at 4.07 meters. So we have M max. And then we have this value equal to 20.36 into 4.07. Then we have minus due to UDL. That is 5 into 4.07 into 4.07 by 2. And we have couple that is plus 40. And then you can solve this. So we have 20.36 into 4.07 minus 5 into 4.07 square by 2 plus 40. And it comes 81.45 kilonewton meter. 81.45 kilonewton meter. Then we have to find left of C. So left of C. Now I will take from right side, and then we have this as 14.64 clockwise plus 2. Then we have due to UDL minus 5 into 2 into 2 by 2. And then we have this as plus 60 because anti-clockwise. And from this we will get this value 14.64 minus 14.64 into 2 minus 10 plus 60. It comes 79.30. So little bit you can see this. So 79.30 kilonewton meter. Then you can find a right of C. Now what we have to do from right of C? So we have simply 70, right of C you have to take only 14.64 into 2 minus 5 into 2 into 2 by 2, and we will get this value 19.30 kilonewton meter vertical ordinate. And then we have at B 0. So you can see where we have couple, we have vertical ordinate. You can calculate this vertical ordinate. We will have, so we have this vertical ordinate. This is 3470.72 minus 30.72. So this vertical ordinate we have 40, and here you can have 79.30 minus 19.30, so 60. So likewise, we will get these values of bending moment, and then we have to plot it. And then second problem we have in this. So now in this problem, we will go moment about D0. Generally, where we have overhang, do not take moment about that reaction because it will be little bit confusing. So we have 2, total span of UDL is 8. It will act at center. So we will have this 2 into 8, and this will be 4 meter from this, plus 3 from here. So 2 into 8 into 7. Then plus 8 into 3 minus RB into 8 equal to 0. And from this we will get RB, that is equal to, we have this value 17 kilonewton. And now you can have summation Fy0 equal to RB, then minus 2 into 8 minus 8 plus RD equal to 0. And then we have this as 17, 8 to the 16 plus 8, 24, this 17. So we will get RD 7 kilonewtons. So we have RD 7 kilonewtons. So now knowing reactions, RB 17 kilonewton and RD we have 7 kilonewton. Now we will go shear force diagram. So shear force. So we have first. Now I will have this as A, B, then this will be C and D. So at A, 0. Then we have left of B. So left of B, we have 3 meter and 2 kilonewton per meter UDL. So minus 2 into 3, minus 6 kilonewtons. Now you can have this as x to the power 0. So we should have this x to the power 1. Then we have third. So third we have right of B. So we have third right of B. Right of B. And we have this as minus 6 plus 17 equal to 11 kilonewton. So we have this as 11 kilonewton. Then we have left of C. So we have fourth left of C. Left of C. So we have to consider whatever UDL we have in this portion, which is 2 into 5 meter. So it comes 1 kilonewton. So you can see left of C we have 1 kilonewton. As we have UDL in loading, so automatically it will be x to the power in SFD. Then we have right of C. Right of C. So we have 1 minus 8. So we have minus 7 kilonewton. So we have this as minus 7 kilonewton. And then we have a left of D. Value remains same, no load is there. So minus 7 kilonewton, so horizontal line. And then a right of D we have 0. So seventh we have a right of D, and that is equal to 0. And then we have this will be SFD in kilonewton. Now go for BMD. So now for BMD, we have bending moment. So we have bending moment. So first we have to find bending moment. that is at A. So we have first at A, we have value as 0. At A value 0. Then we have at B. So at B we have due to UDL, which will be anti-clockwise. So minus 2 into 3 into 3 by 2. And this value we have minus 9 kilonewton meter. So we have plotted this minus 9 as bending moment decreases, so that slope increases. We have maximum slope over here. And this is x to the power 1. So automatically we have this as x to the power 2. Then we have to find third at B. Then we have directly at C. So we have this point. Now you can come from right or you can come from left. So if you will come from right, then we have value of RD at 7 kilonewton and RB we have 17 kilonewton. So it becomes very simple, that is 7 into 3, 21 kilonewton meter. Or you can come from right, left. So we have at C, and we have this value equal to minus 2 into 8 into 4 plus 17 into 5. So we have 8 4s are 32. So minus 64 plus 85, and this is again 21. So you can come from any side, you will get same. So and then fourth we have at D, we have this value equal to 0. So we have to actually plot 21 and then we have 0. Then you can see here we have x to the power 1 in SFD. So in BMD x to the power 2, it is x to the power 0. So we have it is x to the power 1. So likewise, we have to solve the problems. So now we will stop here only. Remaining part we will see in the next video. Thank you.